Hi, welcome to real-time data and analytics for energy utilities using ArcGIS Velocity. Thank you for joining us. I'm Mariah Salazar. Today's presenters include Kyle Crawford. Kyle is a solution engineer from the utilities team. Hi, Kyle.
Hi, everyone. Thanks for joining today.
Pat Hull. Pat is the industry manager for electric. Glad to have you here, Pat.
Thanks for having me.
Ken Gordon. Ken is a project engineer from the ArcGIS Velocity product team. Ken, we are very glad you could back up the utilities team with your expertise.
Happy to be here.
This webinar includes several polling questions. Please participate in the polls. We appreciate your responses. I encourage you to post questions in the questions dialog box during the webinar. We will answer as many questions as time allows. At the end of the webinar, a survey will launch. This is a short survey. It will only take a minute. Please complete the survey. There are only a few questions. Kyle, you've been working with real-time data. Show us what this looks like.
All right, thanks, Mariah. So does anyone know what the most requested map in the world is? Well, it's a weather map. As individuals, we look at weather forecasts to help us prepare for the day. Whether it is how we decide to dress, plan for outdoor activities, or what items we need to grab right before heading out the door. Say, an umbrella. And most of us has experienced that time, right? Where you're sitting in your car during a rainstorm, trying to decide whether to make a run for the door, wishing you grabbed that umbrella. And similar goes for your organizations, but at a different scale because you provide essential services to the public. And it's crucial for any utility to monitor active weather events and be able to determine what kind of impact those can have on the network, staff, and customers. You might rely on weather to plan job assignments, power production, or the extra gear needed to keep employees safe. But most importantly, it helps to prepare and respond to severe weather events like wildfires, hurricanes, and flooding. To prepare and respond to events, we rely on many disparate data points. But today, we are going to cover how we can capture these data points to aid us in predicting and preparing for real-life events. What we're looking at now are natural gas transmission lines and processing plants throughout the Gulf Coast region of the United States. And the first thing we might do is bring real-time information, such as weather radar, to provide a quick view of the current weather situation. Now, we may also want to leverage some other content that is shared through the Esri Living Atlas, such as weather warnings that were issued by NOAA. And those can vary from fire watches, to flood advisories, to hurricane tracking, or for when the seasons change, blizzard warnings. Now this layer is updating whenever NOAA has an update, so as soon as they publish a new weather warning, we're going to see it reflected here in our map. Now in this region, we are looking at a flash flood watch that has been issued. These warnings and watches can inform us of any storm that might encroach our service territory. And because we could be facing a flood situation, we can also leverage the live stream gauge layer from the Living Atlas, which contains near real-time measurements of water depth from multiple reporting agencies recording at sensors across the world. Now, visually we can start to identify certain trends between these datasets, but I've gone ahead and leveraged the capabilities of ArcGIS Velocity to fully assess the potential impacts these kind of events could have on my utility. In case of a major flooding event, the gas pipes in my network could be subject to erosion, damage, or water intrusion. And by leveraging the analytical functions of ArcGIS Velocity, we were able to calculate how many miles of transmission lines are currently within these flood warnings. It also enabled us to create these lists here that are showing specific transmission segments that intersect these flood warnings. I could of course click on one of these segments, and it's going to highlight that part of the network. I can also review information from those live stream gauges, or bring in additional sensor feeds to improve my situational awareness. So now I'll kick it over to you, Pat.
Well, thanks, Kyle. Clearly, real-time information holds a lot of value, but that value is different for each of us. So I'd like to run a quick poll here. How would you like to use real-time sensors and data in your work? How do you plan to use those? Would that be SCADA or some form of remote monitor, maybe weather feeds as Kyle suggested, AVL, or something else? We'll give you just a minute there. Okay, we have some good responses. Let's close that and take a look.
So it looks like the audience, a majority of the audience is using SCADA at 63%. Remote monitors is a close second, Pat, with 54%. And then weather feeds at 43%. and then vehicle locations at 32%, and then other at 19%.
Very good, thank you. Well, that makes a lot of sense to me. I think a lot of people, we have thought about weather feeds, we thought about AVL, but in utilities, in terms of operations, our mind immediately goes to operations and getting that SCADA data. And we're going to see how we can put some of that data in the field here later on. I want to take just a minute here to look at 3 trends in the real-time space. The first is innovation, then the increasing number of connected devices that we have to deal with, and the use of cloud technologies. I'm really excited about this because Velocity makes it very straightforward to get rather impressive results quite easily. The senior leaders that I talk to, they are looking for innovation. They want to find ways to use technology to work better. I sometimes hear people say that we have an innovation imperative because real-time data has moved from a nice to have to a must have. With it, we can anticipate problems, we can troubleshoot more effectively, and we can even work more safely. The world is much more connected than ever before, and we are adding devices all the time. This is even true in our personal lives with things like video doorbells, and true for utilities as we add more and more sources that can help us be more effective. The devices themselves are smarter, but they also capture huge volumes of data. An example is my Ring doorbell. It does this. I told it what to watch for. It alerts my phone when it sees motion, and it stores that video in the cloud. But real-time data can be very tricky to use because it comes in far too rapidly to really understand it without some good tools. The data has to be managed, and it has to be made available. Most of it is simply plain old boring information, but we need to know when it gets interesting and when it's trying to tell us something. Here in the Western US, we've had many recent wildfires, unfortunately. In fact, the now infamous gender reveal fire from last year started right up the street from my house. And I got a close look at how the utility responded. And one of the things that they did was install new monitoring stations like this one on the right that tracks conditions and winds and helps them with their fire models. When I worked for the power company, we started, as Kyle said, with real-time weather feeds, lightning strikes and high wind warnings. And then we looked to AVL, real-time vehicle locations. These are very common starting points for utilities with real-time information. Soon, however, we added remote circuit indicators. At substations, we added battery monitors, various temperature monitoring devices. But here's what wasn't great. Each of those things had its own dedicated interface, and they were not well integrated into our workflows because we had multiple screens to watch. These were point solutions, and the information wasn't widely available, and we certainly didn't have it in the field. Fortunately, technology caught up with our need to put real-time data to work, and we're going to see that Velocity makes that very straightforward to do, to ingest all those real-time data feeds, to view them on maps, to overlay them with your facilities, and analyze them consistently. And then, maybe most importantly, alert you when something needs attention so that you can take action. Here's our agenda for the hour. I'll lay a very quick foundation for handling real-time information. And then Kyle is going to open the hood and he's going to take us through how to do this. Pulling in real-time information, no matter where it comes from, performing analysis on that data, and then also acting on the results. Following that, I'm going to do a short FAQ with Ken that you met a minute ago from the product team. I'm really excited about this because I want to cover some of the very common questions that seem to come up a lot. And we will save time for your questions, so please type them in as we go along here. All right. Velocity provides 3 main capabilities. You can grab onto real-time data from almost anywhere, from cloud frameworks or vendor APIs. And that streaming data can grow very quickly. Velocity was made to handle that. It has the processing horsepower to analyze events measured in tens of thousands or more, and to make calculations and detect very specific things. Finally, it enables you to act on that information and put it to work somewhat automatically, writing it to a layer, pushing it to another cloud hub, sending an email, or even a text message. Velocity is fast. It's very easy to deploy, and it's highly scalable. That's a key recognition, is that it's very highly scalable to deal with large volumes of information. And here is what's really excellent, is it does all of that with a very low administrative burden. All right, you're going to want to watch this closely. Some of you gave us feedback in prior webinars that you wanted more detailed content, and that's what we have for you. Kyle has some on-point examples of utility uses. So Kyle, I'm going to hand it off to you now to show us how this works.
Thanks, Pat. So what we'd like to do with our time today is really show you how this works in practice, piece by piece. So first I'm going to walk through how to easily bring in real-time tracking data with an example of fleet monitoring. ArcGIS Velocity is a capability of ArcGIS Online. Upon adding this to your ArcGIS Online subscription, you can quickly access the application from your app launcher on your home page. This takes you to a simple-to-use web application where users can author feeds and analytics. You don't need to be an admin or an IT or even a GIS professional to use this application. And this capability can be enabled for anybody in your organization. One of the first things you'll often do with ArcGIS Velocity is configure a feed. Feeds are ways for you to consume real-time data sources to be visualized on a map and to be used in analysis workflows. Before I configure my feed though, let's go look at a dashboard where I've already configured a common feed that is used in the industry. On my map, I can see current vehicle locations being streamed in from our AVL solution. This is all possible by connecting to this data through a feed. With all this GPS data, you might be interested in understanding information like vehicle utilization rates and whether there's a need to reduce or increase the size of your fleet. We can also calculate statistics like how many kilometers are being driven every day, as well as break that figure down by specific employees. And we can even go a step further by displaying this data over time. With this information, you can look at opportunities to help to reduce transportation costs, improve worker safety, and then ultimately make your operations more efficiently. So now let's look at how we can configure a feed so that we can visualize these vehicle tracks. So we're now back on the application homepage where we can create a feed. When you create a feed, first you specify where your data is actually coming from. Your feed could be coming from ArcGIS. So this could be a feature layer that mobile users are collecting data into with mobile apps such as Survey123, Quick Capture, or Field Maps. You can also connect to different cloud IoT service providers such as Azure, Amazon Web Services, and Cisco, and from commonly used web and messaging systems and protocols. These include messaging brokers like Kafka, RabbitMQ, and MQTT. I can also even configure a feed to receive data from an external API, which can send data via post requests directly to Velocity on a REST endpoint that I set up. And finally, we've added support for some of the most common AVL providers as well, like Verizon and Geotab. To access my vehicle GPS locations, I'm going to connect to an Azure Event Hub, where we're streaming the GPS data to from our AVL solution. First, I need to configure my connection with Azure by providing a name, an access key, endpoint, and entity path. Upon establishing my connection with Azure, Velocity will then connect and auto-discover the schema of the incoming data. And then you can check the attributes, rename or remove fields, or change the data types as needed. In here I can see I've got a timestamp field where I can change the field type from an integer back to a date. Then you have the ability to enable this data to be viewed on a map, and to allow us to perform spatial and temporal analysis. And to do this, you just need to specify a couple of key fields. This includes the location information, which in this case are my latitude and longitude, as well as the spatial reference, which you can choose from the vast coordinate system library to match the incoming coordinate system of your data. You also specify the date and time that this record was captured. Then finally, you can provide a tracking ID, which is a unique ID associated to each vehicle or asset that's being monitored. So for vehicles, this could be the VIN number of that vehicle. With my feed fully configured now, I just need to provide a name and a description. It'll take just a few seconds for the feed to initialize, and I'll be able to view this data in the map. ArcGIS Velocity is spinning up these long-running jobs that are hosted for you entirely in the cloud. They continuously ingest data, parse it based off of how you've defined it, and enable it to be used in ArcGIS. These feeds are then visualized as what are called stream layers. They display data immediately in your web maps and applications because they're continuously subscribed to the service which is pushing data. Now, once my feed is initialized, to view my data, I can quickly add it to a new map with the Open in Map Viewer button. This will take me directly to a map, and I can zoom in to look at my live vehicle locations updating. So just like that, we've got these vehicles moving on the map. My map is live and dynamic, always showing the newest data. And users can look to this map to then understand where their workforce is, coordinate work in the field, and run their operations more smoothly and efficiently. So now let's discuss more about feeds and how we can perform analysis on these to gain some business insights. So what you just saw there is essentially the first step in leveraging real-time data, which is simply accessing sensor data and bringing it in. Configuring feeds in Velocity is an easy-to-use guided workflow. It lets you directly and seamlessly connect to external sources of observational data like Internet of Things platforms, message brokers, or third-party APIs. They automatically derive the scheme of the data as you saw with the vehicle's information, and they allow you to revise your data model on the fly. Then once they start up, you simply add them to a map to immediately see the real-time information and combine it with other data. So this provides both system integration and situational awareness, configured in minutes without writing any code. And bringing in data with feeds is just the first step. With real-time analysis, you can do more than visualize your sensor data. You can immediately put it to use. In Velocity, a feed is the input to a real-time analytic, which can be used to transform, enrich, and detect incidents. Real-time analytics are a flexible model-building capability that let you combine tools and take different kinds of actions. You can store sensor observations over time to a feature layer, send notifications and alerts, or even send commands and triggers to external systems to actuate behavior. So next we are going to use that feed of the fleet vehicles and show how to put automated monitoring practices in place. We're going to be watching for alerts from our systems, track those out in the field, and notify staff of any incidents. And so to see real-time analytics in action, I'm going to look again at our vehicle locations feed that we configured earlier. Feeds provide real-time situational awareness for your operations, and there's a couple of simple things that you can do to turn this map that we created a second ago into a valuable information product for operational awareness. First, I brought in an additional feed that I've configured. This feed displays real-time temperature data coming from sensors installed on our transformers. I've also configured this symbology for my vehicles here to show both where vehicles have been, showing an historical trail of their locations, as well as where they're going by orienting these arrows in the direction of the bearing of the vehicle based off an attribute we're pulling from the AVL system. But the true value of ArcGIS Velocity is in the analysis capabilities. I have this data that we've brought into ArcGIS, but what do we do with it now? How do we derive insights from the data and display that then in a map? So to go beyond just viewing these feeds can be a really big challenge, especially when dealing with these large volumes and high velocity data such as these vehicle tracks. So to make use of that data, what we can use is the real-time analytics tools in ArcGIS Velocity. For example, it seems here that I've been alerted of a set of transformers that have been operating at an abnormally high temperature for an extended amount of time. These events can easily be detected and then automatically dispatch the closest employee in the area to assess the situation. These alerts and notifications are happening in real time without the need to pick up a radio. So now let me walk you through how this is being accomplished using a real-time analytic. It starts with going back to the Velocity application, and to create a new real-time analytic, I'll select this button here and it gives me the option then to either create a new feed from scratch or select an existing feed, which is where I would select that previously created vehicle GPS tracks. But for the sake of time, I'm going to walk you through a real-time analytic that I've previously created to run the analysis we just saw. In this model view that we're looking at right now, you have a simple to use graphic interface for configuring your analytic models. On the left side, I've brought in these two data feeds, one being the vehicle tracks and the other are temperature sensors. Bringing in these feeds is easy by navigating to feeds and either creating a new feed or selecting an existing feed. You can also make use of static data sources stored as an ArcGIS feature layer or data stored on an Amazon S3 bucket, Azure Blob Store, and others. This could be anything from service areas or transmission corridors that could be used for geofencing enrichment or summarization workflows. And for analysis at the top right, I've got a couple of different tool sets, such as ones to find locations, managing data, summarizing data, or using proximity. So now let me walk you through how we can string these tools together to create a complete workflow. So like I said, we have our two inputs, which are both feeds. The feeds create two branches to this analytic, and the first is processing sensor data, and the second is another branch processing the vehicle GPS tracks. So let's talk about the temperature sensor data first. In this case, our temperature is recorded in Celsius, so we can easily use the Calculate Field tool to create a new field that will also provide temperatures in Fahrenheit. Next, to stay aware of any unexpected behavior within our data, the Detect Instance tool is used. This tool evaluates features against a set of opening conditions and optional closing conditions and creates an incident. In this case, I want an incident to be created whenever a sensor goes above 60 degrees Celsius and close the incident if it falls back below 60 degrees Celsius. From there, we branch off into two directions. One will store all the detected incidents that are created, and the other will filter for any incidents that last longer than 5 minutes. This serves as an indication that the sensor is not just detecting an anomaly, but instead a serious incident. And as we've done previously, we are choosing to store these records to be used for historical analysis. We also have an ArcGIS feature layer that provides the latest sensor alerts, which we use to display within the previous dashboard. These results are then being used as an input into our Calculate Distance tool. Well, so what do we do with that information? Well, we also have this vehicle GPS data feed, which we first want to go ahead and do some data management before it reaches our Calculate Distance tool. This tool then uses the data inputs to locate the closest driver within 200 meters of the alert to be dispatched. This is an amazing capability because in this case, we're actually using two data feeds to conduct dynamic geofencing on the fly. After we've located the closest driver to dispatch, we can calculate a path between the alert and the driver to indicate this connection within the dashboard. Up to this point, we have ingested our data feeds, conducted proximity analysis, and now we want to notify both office and field staff of the current situation. This can easily be done by taking our Calculate Distance result, refining a few fields, and then sending email and text message notifications to the appropriate staff. For instance, when the temperature sensor alert was created, I instantly received an email notifying me of the situation. And the text message was sent out to notify the closest driver that they have been dispatched to respond to the incident. Within this text message, I have a link out to field maps that allow me to view some more information when I get to this area. I can see the alerts here within my map, and I also can see the live temperature sensor data coming in while I'm out in the field. So we've seen how ArcGIS Velocity helps you to rapidly ingest live data with feeds, as well as real-time analytics help you to perform real-time geospatial analysis on those feeds. By leveraging a completely cloud-hosted solution, some existing GIS data, as well as some simple configuration tools, you can build a valuable application for any operations group in a matter of minutes. So now let's learn more about the power behind real-time analytics, as well as where we can take these large amounts of data that we're acquiring. So real-time analytics provide processing horsepower to your tracking and sensor workflows. Instead of requiring custom-built applications that need to incorporate complex streaming analytic code bases, really any end user can assemble an end-to-end workflow to detect incidents and capture data. Real-time analytics process each message from a feed continuously as they arrive, and they can leverage static data sources as well to serve as geofences or enrichment data, which I was doing with the closest driving alert. You can combine different tools together in a workflow to ask any number of questions and associate different output behavior with each one. In some cases, you might store data, which I was doing with historical alarms, whereas in others, you might send alerts or a command to a third-party system. Overall, real-time analytics are useful when your decision timeline is operational, when you need to know about something and take action immediately. Velocity supports these kinds of patterns because there's a focus on integration with external systems. There's an extensive support for different real-time and big data systems and various data formats. These are aimed at covering major commercial IoT platforms as well as common real-time messaging technology. The approach, especially for real-time scenarios, is to also aid in getting your data into and usable within ArcGIS. In other words, the data doesn't have to already be in an ArcGIS layer to be leveraged. And if you are detecting incidents or finding particular patterns, you can use those findings within our systems through these different supported outputs. For example, Azure or AWS IoT Hub could be leveraged to access data from a SCADA system and make it available externally. And polling a website enables you to access any number of sensor vendor APIs. Beyond real-time visualization and analysis, you can also work with information you store over time. So far what you've seen is me using a feed to bring in and visualize real-time data. These of course get used in real-time analytics for immediate awareness of incidents. And real-time analytics of course can store observations over time to a feature layer. However, as data arrives in real time, these historical datasets can grow to large volumes extremely quickly. Even just 100 messages per second grows to 9 million records within one day. And for that reason, ArcGIS Velocity is designed to grow with you. It includes configurable big data analytics, so you can process this information for trends. These big data analytics can be run ad hoc, but they can also be scheduled and run in near real time to support different workflows. So there's a lot of extra capability here to unpack, and what I will do next is walk through a few examples of big data analytics, both in terms of the scheduling processing, as well as ad hoc traditional pattern analysis. Alright, so to understand big data analytics, first we're going to look at how you can perform near real-time analysis by scheduling analytics. And for this, we will leverage the first example that we covered, which looked at weather observation data to understand the possible health and safety impact against our workers, as well as our operations. So, how can you currently anticipate and prepare for these impacts? Well, let's go back to ArcGIS Velocity and see how we can run this type of analysis. So here, we'll use the same model building experience as we saw with the real-time analytics. We start out by bringing in the data we want to use for this analysis. For this case, we want to look at our natural gas pipelines as well as severe weather events that are coming from NOAA, which can be found in Esri's Living Atlas. The weather warnings produced by NOAA contain many different weather events, but for this use case, I only want to look at flooding events. I can easily filter out these events by using a filter by expression, which is found in the Managed Data tools. We can then overlay these two datasets to find the assets that could be impacted by these flooding events. I can then calculate the length of the pipe segments that fall within this intersection, along with the date field to indicate when this analysis was run. Finally, I can do some data management before outputting this data as a feature layer. Now to put this in actual operation, you can choose to either run this once, or choose to run it at recurring times. For example, if I chose the recurring time option, I can run this every night at midnight. Or you can schedule the analytic to run on regular intervals, such as every 15 minutes. Which is what I will do because I know that's the frequency with which the weather watches and warnings layer is updated. So with just a handful of steps, we can leverage the data that comes from Esri's Living Atlas to implement workflows like these to help improve the health and safety of your workers as well as your assets. Now with this example you saw, these tools weren't used necessarily for big data, but they're more so for recurring analytics that you can use to achieve near real-time analysis through that scheduling capability. But now I want to go look at one more example where we're actually handling much larger data sets. So as an operating utility, there's a high chance you've deployed an advanced meter infrastructure. Accompanying that is meter data management, and because this meter data is very large, it becomes difficult to get your head around what's really happening. But with ArcGIS, we can easily visualize this data and start to answer important questions. Here we're looking at over 250,000 historical electric meter readings. Now I can select individual records to view the related information. This meter recorded a usage of 3.5 kilowatt hours, and that's pretty significant usage in 15 minutes. But what happens over time? By leveraging the big data analytic capabilities of ArcGIS Velocity, We could first collect and summarize this data to look for patterns so we can start to make sense of all this information. And since this data is time enabled, I can step through this particular day 15 minutes at a time. The darker areas are an indication of high usage, which could affect the transformers. What if I wanted to take a deeper dive into this data? What if I wanted to find customers who continuously have a high meter usage, say from charging an electric vehicle, running a spa, and an electric water heater for hours? To answer this question, I used the analysis tools within a big data analytic to find customers who recorded a sustained higher than normal meter load. We can see here that throughout this particular day, we identified several customers, including this one, who recorded a sustained meter load for over 8 hours. This can start to create a real challenge for facilities and cause a potential overload, because most of these facilities were not installed with that kind of load in mind. Now that we have this insight, let's open up ArcGIS Velocity one more time to show how easy it can be to analyze big data sets within a big data analytic. Again, this all starts by bringing in your data that could be stored in ArcGIS, an Amazon S3 bucket, an Azure Blob Store, or from other data sources. We then first want to aggregate our data, which will collect and summarize our meter readings. And because this data is time enabled, we can set a time step interval to be used, so then we can go ahead and step through this data 15 minutes at a time. We then can utilize the detect incidents tool like we did within a real-time analytic to detect specific incidents that we might be interested in. This is also a great time to mention that even though the interface for creating real-time and big data analytics is very similar, they both include some different tools. For instance, within a big data analytic, I have access to tools that analyze patterns as well as additional find location tools. I encourage you to take an extensive look at all the tools that are available because you never know what you might need. So to finish up this analysis, I want to filter my detected incidents to find those data points that meet a specific time duration. Then finally we do some field cleanup before my data is stored in an ArcGIS feature layer. Now I want to mention, just like there are options to bring data in from many sources, you also have the option to store these outputs in other locations as well. So say you were using an Amazon S3 bucket for your input, you can then take your output and store it there as well. So that wraps up our demos for today. So let's do a quick recap of what we just saw. So these big data analytics allow you to analyze data that you store over time as it grows and becomes more and more unwieldy to work with. That's where these big data analytics can be helpful. They're running in the cloud and they parallelize information through Spark to get large jobs done quickly. You can run analysis either on feature layers with data that you have stored over time, or cloud big data stores that are fed from other organizational systems. Much like real-time analytics, you can stitch different tools together in an automated process and create multiple information products at the same time, on the same data. It's also important to note that the same outputs are available for big data analytics, so you can take automated action in your IoT system based on overall system status. Big data analytics are useful when you need to make a decision regularly based on standard practices, or strategic when you need to learn over time and adjust larger approaches. There's a wide variety of spatiotemporal analysis tools included in ArcGIS Velocity. This includes tools for summarizing data, detecting different kinds of incidents and behavior, analyzing patterns, and leveraging spatial proximity. These are largely the same tools that are available through GeoAnalytics. But this also includes tools and concepts from GeoEvent Server that focus on tracking and movement analysis, like calculating motion statistics, summarizing journey and trip information, and snapping tracks to a road network. All these tools can be used in big data analytics, and those that can operate on a single message at a time also work in real-time analytics. So both types of analytics in ArcGIS Velocity can generate output layers for visualization of time-enabled data. And there's 3 basic types. Stream layers visualize new data as it arrives. They're also based on WebSocket technology, so that the map is actively connected to the underlying real-time server. Then we have feature layers that visualize data once it has been stored, and they're the most common layer used in the ArcGIS platform. So to visualize data from feature layers in near real time, you can set a refresh interval so that you can requery information every few seconds. And then finally, when you create a feature layer in ArcGIS Velocity, it also creates a special kind of map image layer. This supports dynamic aggregation of high volume data, so you don't have to try to draw millions of features individually. And so all 3 of these layers can be created through the analysis tasks and used in dashboards and apps to visualize this information and improve situational awareness. So now I'd like to pass it off to Pat to cover some key takeaways from our time today.
Thanks, Kyle. That was very thorough, and boy, you covered a lot of ground. I'd like to pull just a couple of key ideas there from what you showed. First is the simplicity of using so many different data feeds and making them visible and useful. Pulling in all of those different types of data used to be very hard to deal with. Second is the sheer power of the scalability using cloud resources. Velocity is cloud native. It's designed to leverage native cloud capabilities and to be scalable. So it can handle those large volumes of data. And there are so many analytic tools there that are convenient to set up. People have been asking questions about those tools, and we will definitely provide a link to the documentation that shows you where all of those tools are so that you can look at them. Finally, you hit some of the ways to really use these results in the organization. You can drop that real-time information into dashboards or send alerts and even show it in the field. And I hope that everyone caught that, because you showed the transformer temperature sensors in field maps on your phone, and it was kind of quick, but to me, that was a real highlight, because as we saw in the poll at the beginning, I know there are a lot of people that would really love to have SCADA feeds, for example, visible in the field. Really well done. Well, as I mentioned, I get some frequent questions about this, and I'm very pleased to have Ken here with us today to help address those. Ken, it's a treat to have you. I really appreciate you joining us. One of the common questions is around the name ArcGIS Velocity. Some people are not 100% clear. So first, is ArcGIS Velocity the same as analytics for IoT?
Oh, sure, Pat. It's a common question, and ArcGIS Velocity was originally released as ArcGIS Analytics for IoT, but we soon decided to change the name with the intent to reflect its broader range of capabilities than only integrating with formal IoT platforms. So basically, new name, same great software.
Yeah, that's great. That clears that up. Okay, so here's the next one. Is Velocity just a cloud version of GeoEvent Server? What's the difference?
We get this question a lot. And in short, no, they're very distinct from one another with architecture and code bases that are completely different. For example, GeoEvent Server runs on premises on your own servers as a component of ArcGIS Enterprise, and you're responsible for administration and security of the environment. And you can utilize it off the public internet and behind your own firewall. So Velocity, on the other hand, is a SaaS and runs in Esri's geospatial cloud as an extension of ArcGIS Online, which means we handle the security and administration. So you access it via the public internet using your ArcGIS Online credentials. And while admittedly they both do many similar tasks, especially real-time processing of feeds, Velocity has broader big data capabilities and can ingest and analyze data faster and in greater volumes than GeoEvent Server can.
Perfect. Okay, so to be clear, and we've had a few questions on this during the webinar, can we use Velocity with ArcGIS Enterprise?
Well, ArcGIS Velocity is a Kubernetes system under the hood, and while at present it does not integrate directly with ArcGIS Enterprise, it is not part of the ArcGIS Enterprise system. You can leverage ArcGIS Enterprise with it, and Velocity can read directly from feature and stream layers in ArcGIS Online and ArcGIS Server and write to online hosted feature layers or stream layers. So for example, you could push from Velocity to a feature layer and visualize it using a web map or perform analysis using ArcGIS Pro. And similarly, Velocity can watch feature layers that are updated using ArcGIS Web or field apps and then process that data in real time or big data analytics.
Okay, last one. And we also got some questions on this during the webinar. Could you differentiate for us the difference between big data and real-time data and the analysis of those things?
Sure, common question. So basically, big data analytics perform batch analysis on large volumes of stored data, such as data in a feature layer or in cloud big data stores like Amazon S3 and Azure Blob. These are well suited for summarizing observations, performing pattern analysis and incident detection on extremely large data sets. Real-time analytics, by contrast, run continuously and process data being ingested via a feed, analyzing or transforming each individual message in real time as it is received. And this makes real-time analytics especially suited for geofencing and incident detection because they can send alerts immediately when they detect a given set of conditions.
Okay, perfect. Well, thanks, Ken. I really appreciate your expertise in joining the utility team here today. Mariah, we have saved some time as we promised, and you've been tracking our questions from the audience. Let's go there. What do we have in terms of audience questions at this point?
Well, we have a question for you, Pat. What is ArcGIS? Is it a generic term or a brand name?
Okay, I'll be happy to answer that one. This is a fairly straightforward question. Traditionally, many of our webinar viewers are users, but some are not. And so I really appreciate this question. ArcGIS is the product name for Esri's geospatial software system. Now, that's a bit of a mouthful, but people have called this in the past computerized mapping. It's the way that you can view and edit and manage, analyze and share data about whatever it is that you care about, in this case, utilities, by location. I like to call it location technology because it summarizes, encapsulates in just a phrase what it means. And ArcGIS works on the desktop computer, on mobile computer, on the web, and as we've heard today, even in the cloud. So that's the overarching product name for our suite of solutions that help do these kind of things. Would be happy to talk with you more about that after the webinar.
Thanks, Pat. We have a question for Ken. Is there a way to test drive velocity?
Yes, yeah, that's commonly asked or requested. And the way you would do that is to request a 14-day evaluation through your Esri account manager. And it's a simple process.
Thanks, Ken. So if you're interested in working with your account manager to trial velocity, please fill out the survey at the end of the webinar and indicate that you'd like a sales follow-up. We will have your account manager reach out to you. We have a question for Kyle. What are the platform requirements for installing, leveraging velocity?
That's a great question. So ArcGIS Velocity is it's a hosted SaaS, so a software as a service solution. And so there's no on-site server requirements. It serves as a companion to ArcGIS Online, and it has a similar in terms of administration of the product.
Thanks, Kyle. Ken, we have another question for you. I think you touched on this a little bit, but when is ArcGIS Velocity available for ArcGIS enterprise deployment or in a customer's own cloud environment?
Sure, yeah, and we get this asked this quite a lot. As I mentioned before, ArcGIS Velocity is it's a system built on Kubernetes, and while it's only available with ArcGIS Online right now, integration with ArcGIS Enterprise is on the roadmap, and we're estimating it for release in Q2 or Q3 of 2022. So when that happens, you will have the option to run ArcGIS Velocity in a Kubernetes environment, in your own cloud environment. And that will then provide the real-time and big data capabilities for ArcGIS Enterprise.
Thanks, Ken. Kyle, we've got another question for you. Does Velocity consume ArcGIS Online credits?
That's another great question. So no, ArcGIS Velocity does not consume credits. Velocity is a subscription that comes with a predefined amount of compute and storage. And it's also designed to bring in high velocity data and store high volume data. So the ArcGIS Online credit model does not apply to ArcGIS Velocity. And we can also help size Velocity based on your needs to understand what subscription would be best for you.
Thanks, Kyle. And another question for Ken, with Velocity being a SaaS solution, can it be integrated with non-ArcGIS platforms?
And absolutely. We, of course, Kyle demonstrated a lot of integration with feature layers, but we can also read data from cloud messaging platforms, things like Kafka and MQTT, RabbitMQ, as well as industry IoT platforms like AWS IoT and Azure IoT Hub. And that includes both input and output opportunities.
Thanks, Ken. And then we do have another question for you. Is there documentation that our audience can access that lists all the possible data sources for feeds in Velocity? And then a follow-up question to that is, where can they find all the tools available in Velocity?
Right, and yeah, this is a good follow-on question to that last one. We have all of our documentation online, and there you can, and we'll post a link. We'll include the link to that online documentation with, with the follow-up to this webinar. But yes, we have exhaustive and comprehensive explanations of the various inputs and tools and outputs that are included with Velocity.
Thanks, Ken. And just as a note for the audience, I did include a link in the chat box with a link to some of the documentation on Velocity. So hopefully everyone is seeing that in your chat dialog box. And then just a couple more questions. Does Velocity have network analyst tools such as the create and drive time polygons? I'm not sure if this one's for Ken or for Kyle.
I can take that. This is Ken. And yeah, so Velocity does have the only tool that Velocity currently has that is considered network analysis type is Snap to Network. It does not yet have drive time polygon tools integrated, but we continue to evaluate what customer requirements are, and what people are asking for, and certainly there's always a possibility we include more than those. As we go forward, we will just increase the number of tools that are available in Velocity, and that will largely be driven by client requirements and demand.
Thanks, Ken. I'm just going to give our questions dialog box a quick once over to make sure we're covering all the questions. So this is a good one. Is there a mobile solution that can be used outside in the field as well as in the office?
A mobile solution, well, of course, ArcGIS already includes a number of mobile applications that can integrate with the ArcGIS platform in general, and Velocity as an analytic and data processing engine can read to and or read from those the feature layers that are integrated with things like field apps and mobile web applications and such, and it can also write to feature layers that some of those mobile applications can leverage in turn. So while there's no direct specific Velocity mobile application, it does integrate with the ArcGIS platform and the mobile applications that are available there.
Thanks, Ken. And then another question from the audience. Is it possible to use ArcGIS Velocity for dam monitoring?
For dam monitoring? Generally speaking, yes. Dam monitoring, if there are sensors or data streams that are part of a dam monitoring solution or a dam monitoring system, then ArcGIS Velocity could probably connect to those streams especially if there's some kind of a standard industry standard in terms of the the data feed types and data source. So if you're integrating with an Azure IoT Hub, for example, yes, we can definitely make connections to that and integrate with it.
Thanks, Ken. And I think we got to all the audience questions there. So if anyone has any last minute questions, I'll give you a couple seconds to post those in the chat. It looks like we have another question from the audience about velocity integrating SCADA data directly. Is that possible?
Well, yes, generally, SCADA is, there are a lot of different kinds of SCADA systems, but there again, Velocity integrates with industry standard, messaging platforms and protocols. So, here again, it's worth exploring the SCADA system in use and where the opportunities for system integration exist within that system.
All right, thanks, Ken. And that's about all the time we have for questions today. But before we wrap up, I do have a few announcements. Just a reminder, this webinar was recorded, so please look for an email with a link to this webinar's recording. We'll also include some documentation for the audience, as well as a link to the PowerPoint and any other resources. So at the end of this webinar, a survey will launch. Please take the survey. It'll only take a minute. And if you'd like to learn more about ArcGIS Velocity, visit learn.arcgis.com. We have some great training opportunities for ArcGIS Velocity. In this learning path, you'll find a mixture of articles, videos, and lessons. And please join us for the next energy utility webinar about business intelligence, driving better utility decisions with location technology. It's right around the corner on October 19, and it'll be hosted by energycentral.com. I've included a link in the chat if you'd like to register for that webinar as well. So Esri's Infrastructure Management in GIS Conference, also known as IMGIS, will take place in Palm Springs, California at the Palm Springs Convention Center, October 25th through the 28th. The IMGIS conference is a crossover event bringing together several industries, including electric, gas and pipeline, water, telecom, transportation, and AEC. Register today for access to data health checks, technical resources, industry experts, hands-on support. Early bird registration ends on October 1st, and I'm including a link to the registration page in the chat as well. Here are some ways to stay connected. We post regular content for utilities on LinkedIn, especially Pat, and make use of the Esri Community Forum to get answers and connect with your peers. If social media is your thing, follow @Esri Electric Gas on Twitter to stay in touch. On behalf of the team, thank you for being our customers and partners and for joining us today. This concludes the webinar. Thank you.